Welcome to Lesson 1.4, Graphing Sequences. The objectives are to recognize an arithmetic and geometric sequences from their graph. Also, to use graph to check whether a recursive formula is a good model for use of data. I would like to also add in to recognize shifted geometric sequences from their graph. You will need your textbook. Please open it to page 51. This is the investigation that is on page 51 from lesson 1.4. You'll notice that you have 6 tables, 1, 2, 3, 4, 5, and 6. You have 6 recursive formula that's written right in the middle here, and you have 6 different graphs that you must choose from. What I like you to do is to match the recursive table with this recursive formula as well as with the graph. So you can pause now and try it, or you can continue and let me show you how to get started. Let me take recursive routine A and show you. Right? According to this recursive routine, your first term is going to be 8. Your next term is going to go down by 2. So that would be 6, and then 4, and then 2, and then 0, and continue on. This is when on your 0 term, your first term, your second term, your third term, and so forth. So now I'm going to look for a table that matches my recursive routine, and it looks like table 5 has those same values that I just wrote on the side. So A will go with table 5. Let's figure out what graph it might be. I'm looking at the starting value for each one of these, and I notice that 4 has a starting value of 8. 2 also has a starting value of 8, and those are the only 2. I also notice for graph 2, it's decreasing by a constant amount, and it looks like it's decreasing by 2. So therefore, I can eliminate graph 4 as part of this. So table 5 goes with recursive formula A, goes with graph 2. Pause the video and try a couple more, and then press play again to see if what you have matches what I have. So here's the solution for the investigation. Table 1 goes with recursive sequence B that goes with graph number 4. And again, please pause to check your solution. I just want to summarize this lesson. The general shape of the graph of the sequence term gives you an indication of what type of sequence necessary to generate the term. So for example, an arithmetic sequence have a linear graph. What that means, it is a straight line. A geometric sequences have a curved graph. Same thing if it was a shifted geometric sequence. When a common difference of an arithmetic sequence is positive, the linear shape slopes upward from left to right. So the graph looks something like that. When the common difference of an arithmetic sequence is negative, the linear shape slopes downward from left to right. So it looks something like that. When you're looking at a geometric sequence, when the common ratio of a geometric sequence is greater than 1, the curve shape increases from left to right. It looks something like that. When the common ratio of a geometric sequence is between 0 and 1, the curve shape decreases from left to right. So anything that's between 0 and 1 will look something like this. And generally speaking, it will approach 0. For a shifted geometric sequence, it levels off at a non-zero value. So here's what I mean. If it's increasing, it will eventually level off at what we call the long run value. That was from lesson 1.3. If it is a shifted geometric sequence and it is decreasing, it will level off at a value that is not 0. So it's not going to be approaching 0. So why learn this? And the reason is because one of the career is weather forecasting. And that's one career that relies on mathematical modeling. They use computers and sophisticated model to monitor changes in the atmosphere. The trend in the data can help predict the trajectory and severity of the impending storms, such as a hurricane. So for example, if the trajectory of the hurricane is heading west, then they can guess what part of the United States this storm will hit. So that's one way of using recursive formula, or to use math in real life, in daily life.